inspector and electrician use a thermal camera to inspect the electrical panel. The electrical panel is one of the most important systems of the home, and in many states, including my own, it is not required to be opened and inspected by home inspectors. However, most of us do. Many inspectors, although not all, use a thermal camera to inspect the electrical panel. Now, how does this work? Thermal cameras show the temperature of a surface, or at least the temperature of most surfaces. They will not accurately show you the temperature of metal, for example. But most surfaces in the home, a thermal camera will show you its temperature. For example, you see the drywall in this garage is around 60-ish degrees. When we go to the air vent here where the heat's on, it's closer to about 100 degrees, which is typical for a furnace when it's running in most homes. In an electrical panel, we're looking for heat. If there's an excessive amount of heat, that indicates a fire hazard. If electrical conductors get too hot or their breaker connections get too hot, they will eventually melt and they will eventually start a fire. In fact, when it comes to fires that are started by electricity, it's almost always a loose or damaged connection that causes an excessive amount of heat to build up that causes those fires. That's actually what these AFCI breakers are designed to stop. This is not GFCI, which everyone has heard about. This is AFCI. These are not commonly found in homes, except for newer homes. This home was built around 2004, so it makes sense that there's only a couple of these at the bedrooms. But those are actually designed to stop arcs that can cause fires at loose connections. The thermal camera, however, is intended to show us if there's any excessive amount of heat. So these orange spots, the yellow spots on this thermal camera are the hotter spots. This is the range of the thermal camera, and on the bottom, the reddish orange is the coldest image in the picture, about 53 degrees. And the yellow, the top of the almost white color, is the hottest in the image, about 92 degrees. So you see here that we've got 2 breakers down here that are pretty hot, 3 breakers up here that are pretty hot, and then there's some heat down here as well. So is that a concern, and how do we know? Well, in this case, no, all of those are completely normal, and there's nothing indicative of a problem in this panel. What I've got running right now is the furnace. It's an electric furnace, so it actually has 2 breakers, and it is this one and this one. These are 240 volt breakers. So this is 30 amp breaker at 240 volts, and then a 50 amp breaker at 240 volts. And it's typical for most electric furnaces to have 2 different breakers. You can have them that have 1 breaker if they're smaller, but usually they have 2. And so you see the bigger wires on the bigger breaker. That's normal. That's going to be carrying more current. Let me show you how much current is flowing. It's actually kind of hard to get the clamps around those ones because of how tight it is. So I'm just going to measure the main conductors. These are bringing power into the entire home. And you see here on the right leg, 77 amps. 77 amps, that's a pretty good amount of juice. That's a good bit of electricity that's flowing. And that's between these 2 breakers that are both supplying power to the furnace, as well as the lights, but they're not really drawing much power. And then the oven is also on. So there's several things drawing power, but most of that is the furnace. Now on the thermal camera, this looks completely normal. 90 degrees is not that hot at all for an electrical panel. There's no one size fits all answer for how hot can a panel get, because it depends. It depends on the ambient air of the area that we're in. It depends whether the panel's outside or inside. It depends on a lot of factors. But typically, it's when you get up to 150 to 200 degrees that something may be wrong. But even then, not always. It is possible for many residential panels to get over 150 and still be okay. But I will say in my experience that once they get over 150, there's usually something wrong. But 80 to 90 is typical for smaller circuits, and up to about 100, 110 is not abnormal either. But that's not really what we're looking at when it comes to the actual thermal camera. We're looking more for a heat distribution. So this is what a normal circuit looks like. It'll be hottest at the breaker point, at the connection point, but then it will gradually and slightly decrease in heat as we go down. So 77, 78, 77 again, 79, 81, 82. So that's a gradual heat increase from the bottom of the conductors to the top. And that is what we want to see. It's always going to get hot. It's not possible for something in a panel to have dozens of amps flowing and not get hot. It's always going to produce heat, but it's the heat distribution that we're looking for. I don't have an example today because everything working right now is working well, but if it's got a loose connection or a bad oxidized or a dirty connection, it'll usually be that the breaker is like 10 to 20 degrees hotter than the bottom of the wire. You'll see a major spike. You'll see the point of breaker is very hot compared to the rest of the cable. We don't have that in here, but that's really what we're looking at more than anything with a thermal camera. It's not the actual heat observed, it's more so the spike or the pattern of the heat that we're observing. And when it comes to these breakers up here, you may say they're 95, and that's actually hotter than the furnace, but these are always hot. AFCI and GFCI breakers, there's actually electronics in here, computer chips basically. These always run hot, that is normal. They're always going to be between 80 and 90. And actually, fun fact, if you've ever got a GFCI or an AFCI that is not hot on thermal, it's bad. This is a transformer, probably for a doorbell. They also always run hot, that is normal. So that's it. Basically, we do look somewhat at the temperatures. I mean, if it's over 150 or 200 degrees, something's probably wrong. But primarily, I'm looking for a heat distribution, a heat pattern that shows one area getting way hotter than the surrounding areas, because that's usually indicative of an issue. And I have found many electrical panels where something was loose or damaged, and I didn't see it with first glance, but thermal camera showed that it was really hot, and when I looked closer I saw melted plastic, melted metal. So this is a fantastic tool. It has helped me find many unsafe conditions before, but this panel looks pretty good at the circuits we are testing. Now, one last thing I will say is that we're only able to see circuits under load with this. So even though we've got this tool, which is very handy, you see most of these breakers are just orange because most of them don't have any power flowing. There may be a few that have lights on where there's like a small amount of electricity flowing, but the vast majority of these don't have anything flowing, and therefore they will never show up on a thermal camera. Electricity only produces heat when it flows. So this test is only accurate when something is actually turned on and running.